Hi everyone! Today we will explore server-side rendering and hydration, two powerful tools that can enhance the performance of your Angular application. Let's get started. Open VS Code to create a new Angular application. From a terminal, I type ngn to create a new application. Define the name. I will inline styles, skip tests, and select the defaults for simplicity. Run this command, and after creating the application, open the containing folder. So we have our Angular application with all the files. I will sort the application to check that the Angular application by default is not server-side rendered. So type ngs in the terminal to run the application locally. Navigate to the Angular URL and view the page source for this application. Look that the body is essentially empty. It contains this tag. This tag is used by JavaScript to inject all the content dynamically. So we're not server-side rendering the application by default. So go back to VS Code and stop the application. To enable SSR in Angular, we can type ng-add to add a new capability called Angular/SSR. Execute this command to enable server-side rendering in this application. Select yes to proceed, and it will create all the necessary files and update the current files to enable server-side rendering. So open the Explorer and open this main server TS file to bootstrap the server side from the application. And from the server file, you'll see that this is the setup from the Node.js Express server to server side our rendered application. From the server side render, we'll bootstrap the application, and from the config server, we provide the server rendering. Go back to the add config, and here a new provide line is added, which is this hydration tool that we'll see in a couple of seconds. So I will comment out in this line for a moment. So to check that we're enabled server-side rendering, I will clear the console and type ngs again. Look from the output console that we have the browser bundles and server bundles. Go back to the Angular application and view the page source again. Look that we have some fully static HTML added to this application. From the body, we have this approved tag with this HTML code. So the application is server-side rendered. Go back to VS Code. Let's enable this hydration feature. Hydration converts this static HTML generation into a fully interactive web application. So to enable hydration, we need to add this line. I will remove this event replay option at the moment. I will explain in a couple of seconds. When we enable hydration, let's save it and go back to the Angular application, open the DevTools console, and from the console you will see this output message that the Angular hydrated one component and these 6 nodes. So the hydration feature is enabled in this SSR application. Go back to VS Code and let's take a look at this with event replay option that we can add to a hydrated application. The event replay mechanism catches all user interactions before the hydration is completed. So when it's disabled, some user interactions can be lost before the hydration is completed. When the app is bootstrapped, all these queued events will be replayed in the same order as they happened. So to test that we're not using this event replay option, we'll add a counter in the application and a button to increment this counter. So go to the HTML and we'll add a button. About the content, I will add this element called increment. Add a click event to increment a counted, which is a new variable that we'll define in TypeScript file. We'll increment this counted by 1 and add a p tag to show this counted property. Go to the TypeScript file and define this property. Save it. Go back to the Angular application and look that we have this increment button and the counted value. So how to test this alternative to use event replay when the Angular application is hydrated? We'll go to the network tab and we'll add some throttling. We'll add a slow 4G. And look that when we refresh the application and click this increment button quickly, some clicks will be lost. So press F5 and click quickly. You will experience that some click events, some user interactions are lost. But if we go back to the Angular application and add this option to the hydrated application, the user interactions, in this case the click events, will be queued and will be replayed in the same order as they happened. So let's save it, go back to the Angular application, press F5 to refresh the application and press this button quickly. You'll see that the click events are queued, they are not lost with this event replay feature. Press F5 again and try again. This is a cool feature. Go back. Let's take a look at this app roots server TypeScript file. We can define different render modes per root. We have 3 render modes. The first one is the client mode. Basically, the application is rendered only on the client. We have the server-side render option that server-side render the application before the application is rendered in the browser. And we have the pre-render alternative that basically pre-renders the application at a build time and save all the static files. This is also called a static site generation. This pre-render mode is useful when we're using static views. For example, I will create a new About Us page, which will be an static view, and add this pre-rendered mode. So open a new terminal, navigate to the app folder and add a new component called About Us. Go to the HTML. I will copy a static HTML code. This is a static view. So go to the roots file and define a root for this component with an about path and the corresponding component. Save it, and from the root server we'll configure this render mode for the about path as a printed mode. It will match the same path. So let's build the application. Type ng build. But before that, I will go to the main HTML. I will comment out this sample Angular application, and we'll just keep the route outlet directive to dynamically render a view based on the current root. Let's save it, and the printed mode is added to the about root. So let's build the application. Look in the output console that one static root is pre-rendered. You'll see that the this folder is created at build time. This JSON contains the pre-rendered roots, which is the single about root. And from the browser folder, you'll see that we have this subfolder for the static HTML of the pre-rendered root. So how to save the application based on this folder? So go to the package.json, and to save the application based on the pre-built files, we need to run this command. So copy this command and type npm run, execute this command, and it will run this Node.js Express in this port. Navigate to the about page And this is the static view that we define with the printed mode. So view the page source and you will see that all the content is printed, is static. Go back to VS Code. Finally, we'll add an important validation when we're using an universal app, which runs on both the server and the client side. And this universal app only handles the code that runs in one environment. For example, browser-specific objects like local storage doesn't exist in the Node.js Express server. So go to the root server, and from the about view we'll define a server-side rendered mode. So from this about page, using this server-side rendering mode, we'll try to access the local storage. So go to the TypeScript file and add a constructor. When we try to access browser-specific objects from the server, it will crash the application. So create a new title and access the local storage to get an item based on a key. We'll title and we'll log this title. Let's save it. I will stop in this Node Express.js and just type in yes to run the application locally. Okay, it's already in use. I will remove this console and stop in the application. Go back to the localhost and try to navigate to the about page. And we have an error. So go back to VS Code and look in the output console this reference error that the local storage is not defined, because we're trying to access a browser-specific object from the Node.js Express server, so it will crash the application. To prevent this error, Angular provides a solution to verify the platform that we're using, that the Angular application is running. So we'll inject a token called platform ID. So in the constructor, we'll add an inject function based on this platform ID token. And with this platform ID, I will call a function to check if the code that we're running is in the browser. So call is platform browser. With this function that returns a Boolean value, will pass the platform ID, and we'll only run this code that we're trying to access the local storage on the browser side. So let's save it and test again. Go back to the Angular application and refresh, and you will see the about page is rendered and there is no more errors because we're validating with this platform ID object that we're running the application in the browser. If you want to learn more, don't forget to subscribe. See you in the next video.